Here's the thing about JavaScript. It's not that it's hard, it's that nobody explains why it works the way it does. So today, no fluff, just the concepts that make everything click. This is Coden and let's go. Before anything else, you need to know one weird truth about JavaScript. JavaScript is single-threaded. That means it can do only one thing at a time. Compare that to something like Java or Python running a server, multiple lanes, multiple cars all moving at once. So if JavaScript is stuck waiting on something slow, like loading data from a server, shouldn't the whole page just freeze? Yes, it would, unless JavaScript has a trick up its sleeve. And that trick is called the event loop. We'll get to it, but first let's talk about something even more basic that trips everyone up. Every JavaScript tutorial teaches you var, let, and const. But most skip the part that causes actual bugs. Let's start with var. Here's something that will look wrong but actually works. You're logging a variable before you even declare it. Shouldn't that crash? It doesn't crash, it just prints undefined. This is called hoisting. JavaScript secretly reads through your code first and moves all var declarations to the top of their scope. But it only moves the declaration, not the value. So when your console.log runs, JavaScript knows the variable exists, but it has no idea what's in it yet. This is why it hoists silently, no warning. Let and const don't do this. They have a concept called the temporal dead zone. Try to access them before the declaration and you get an actual error, which is actually better. Because errors, you can see, are better than bugs that can hide. Also, a quick rule is to never use var. Always use const by default, switch to let only when you need to reassign. Okay, now for the thing that makes developers question their sanity. What does this return? Take a second. It returns the string 1, 2, not the number 3. JavaScript saw a number and a string and thought, I'll just combine them as text. Thanks for the help, JavaScript. This is called type coercion. JavaScript automatically converts types behind your back. And it gets weirder. What about this? That returns the number 3. Addition with a string concatenates, subtraction forces it back to be a number. There are rules, but they're not intuitive. This also affects comparisons. The double equal sign does not type coercion. These all return true, even though they're completely different things. Triple equals, which is called strict equality, never does type coercion. And it checks the value and the type. Default rule is always use triple equals. Always. Alright, this next one has a reputation. The this keyword in JavaScript. Everyone's confused by it at some point. The short version, this refers to whatever object is calling the function right now. So in this example, a user object with a greet method, this.name, correctly refers to the user's name. Makes sense, but here's when it breaks. If you pull the function out of the object, now nothing is calling it, so this has no context. It's lost. This happens all the time with event listeners and callbacks. There are 3 fixes: bind permanently ties a function to an object. Arrow functions, they don't have their own this, they inherit from the surrounding code. And if you're using modern classes, which we'll see in a second, this is handled much more predictably. Closures. This one sounds scary, but it isn't. Here's the mental model. Imagine you're going on a trip. You pack some things in your backpack, your snacks, your map, your headphones, and you leave home. Even when you're far away from home, you still have those things. You didn't leave them behind. That's a closure. A function that takes some variables with it even after the outer code has created them that is done running. Here's the code version. Make counter runs and finishes, but the inner function still has the count in its backpack. Call it once, count is 1, call it again, count is 2, it remembers. This is incredibly useful for keeping data private. Count is not accessible from outside, you can't just reach in and change it. You control access through the function. That's encapsulation, a core programming principle done with closures. Okay, remember the single-threaded thing from the start? One lane, one car, how does JavaScript handle slow things without freezing everything? Here's the mental model. JavaScript is a restaurant with one chef. The chef can only cook one thing at a time, that's the call stack. But when a compiled error comes in, something that takes a long time, the chef doesn't just stand there waiting. They hand it off to the kitchen staff. Those are the browser APIs, the browser's built-in features that handles requests like timers, network requests, and events. The chef keeps taking new orders and cooking other things. When the slow order is ready, the kitchen staff puts it in a queue, the line of things waiting to come back to the chef. The event loop is the manager. It constantly checks, is the chef free? Is there anything in the queue? If yes to both, send the next order over. That's literally it. That's the event loop. JavaScript doesn't multitask, it just delegates and comes back to things when it's free. So we know JavaScript handles slow operations in the background, but how do we write that in code? The old way was callbacks, passing a function to run when something finishes. Callbacks worked, but they got ugly fast. Nested callbacks, developer called it callback hell. Then came promises. A cleaner way to say do this, and when it's done, then do this. Better, but the real upgrade came with async and await. Here's the idea. You mark a function as async. This tells JavaScript this function might do slow things. Be prepared. Then inside that function, whenever you wait for something, you put await. Await pauses that function until the slow thing is done. But, and this is the key, it does not freeze the whole page. The rest of your code keeps running, only that one function is waiting. When the data comes back, the function picks up exactly where it left off. And for errors, you wrap it in a try-catch block. Try is where things go right, and catch is when things go wrong. Simple. Async await is just a cleaner way to write promise-based code. Same engine under the hood, better face on the outside. That's 7 concepts that had you stumped, now they shouldn't. And here's the honest truth. These aren't separate things, they all connect. Understanding hosting helps you understand scope. Understanding the event loop makes async await obvious. Closures make callbacks make sense. JavaScript is weird, but it's consistently weird. Once you get the model, everything else falls in place. See you there.